This is the 12th video of the series Business Forecasting, and in this video we will discuss how to perform time series decomposition. So as we have already learned in our earlier video, more specifically that is the video number 2 of this series. So if you have missed that video, I will provide the I button at the top right corner. From there you can check that. So anyway, we were discussing time series components, and in that video also I have discussed three components of time series: trend, seasonality and cyclicality. Just to remind you, what is a trend? Trend is nothing but a directional movement of the time series, either in upward direction or in clear downward direction. So that is known as trend. And what is seasonality? As it is shown here, the pattern of the time series will repeat itself after a certain period of time, and the periodicity generally is 1 year. That means the pattern will repeat itself after 1 year, and within that 1 year number of seasons can be divided, like it can be 12 if it is monthly, and it can be 4 also if it is a quarterly season. And what is the cyclicality? The diagram is little small here. I will draw it once again for you. So cyclicality is like this. So within a span of, let us say, 5 years, 5 to 10 years. So this is say 5 to 10 years. There will be a growth or prosperity, and then there will be, after these initial 5 years, there will be a decline for another 5 years, then maybe for another 5 years there will be a depression, and then it will go to recovery once again. So this is a cyclicality component. So apart from these three also, we had another component that was known as irregular component of time series. So now, first of all, we have to note here that we cannot consider the effect of irregular components in our analysis when we are considering time series decomposition. So then what remains is trend, seasonality and cyclicality. Now look carefully. If you are talking about cyclicality, then either this growth or this decline that is happening over a period of 5 to 10 years. So within that, if you take just 1 year, then it is not much different from the trend itself. So therefore, if you are actually forecasting for a shorter period of time, medium to short term forecast like within 1 year or even 1 year also, then the effect of cyclicality will not be very much predominantly seen in the entire time series apart from the trend. So therefore, there is something called as trend cycle in many textbooks and other texts also. They will combine these two terms, trend and cyclicality, and call it trend cycle altogether. Okay, so there are basically two components. One is your trend cycle component, another one is your seasonality component that need to be taken care of while we are doing the time series decomposition. And then what is the process? The process is we'll first separate out either trend cycle or seasonality, and then project the trend cycle and project the seasonality for the unknown period, and then we'll combine them. So that is the process. And in order to implement that process, we have basically two methods. So I told you here that we need to separate out the trend cycle and then separate out the seasonality and project it for the unknown period and then combine them again. But the question remains here is which one is to be done first? That is, whether we will separate out trend cycle first or whether we will separate out seasonality first and then trend cycle. So based on that order, we have two methods. So the first method is known as the seasonal average method, and the second method is known as classical decomposition method. In case of seasonal average method, we'll first separate out the seasonality component. So remember, first seasonality and next trend. And here the situation is exactly opposite. That means first trend and then seasonality. So in this way, we will implement this in a spreadsheet. Because the method is little elaborate and I need to explain it in detail. Therefore, I am not taking classical decomposition in this particular video. We will only discuss the seasonal average method, that means the first method, in today's video. But before going to the spreadsheet, let me discuss another thing, that is there can be two kinds of models. So one is your additive model, another one is multiplicative model. So what is additive model? In additive model, the trend, seasonality and the irregular variation, these three components will be added. That means sum of trend, sum of seasonality and sum of the irregular component will give rise to the output, that means the forecast. And in multiplicative model, these three figures or these three estimates will be multiplied to get the forecast. But then the question arises here, how will you identify which one is additive model and which one is multiplicative model? That is also very easy. If you see in your data, that means your historical data, that the seasonal pattern is almost constant, like it is neither expanding or not contracting with the trend. So see here, the trend is uptrend clearly, but the amount of seasonality, the extent of seasonality here and here also are almost equal. So if that kind of situation happens, you will select the additive model. So the model is additive, you will know. But suppose the situation is like this, this is your trend, uptrend again, but the amount of seasonal variation here and the extent of seasonal variation here are quite different. That means not actually pattern wise different, but the amount of seasonality, that means the extent of seasonality is greater as we increase the trend. So if such thing happens, then you will select the multiplicative model. So now we will directly go to our spreadsheet and implement the seasonal average method with a particular set of data. So let us now go to the spreadsheet. So here is the spreadsheet. So this is a some kind of airline passengers data. This is freely available in the internet and I have copied this data from GitHub, and I'll provide the link in the description box. So if you want to practice, get the data from that link. So before doing anything, first of all, we will make sure that we work with the time series plot. But before that also, let me give you the introduction of the data. This is a monthly data. You can see the data runs from 1949 January and up to 1960 December. So, and we need to project the data for 1961. That means for the 12 months of 1961, we need to find the forecast. Okay, so, and these are the passengers data. Now, before doing anything, we will make sure that we are working with a time series plot. So we will select the entire range of passengers and then go to insert, here scatter, and select this particular option. So you see this is the chart output, and just by looking at the chart you can say that it is a multiplicative model. Why? Because the extent of seasonality is increasing as we are increasing the period number. So with the trend, the seasonality, extent of seasonality is increasing. So therefore it is a multiplicative model. So anyway, now let us modify the data. So we will insert two columns here. In the first column we will write the period number, because later on we will work with regression, and for that we need to mention the period numbers. So this will simply run 1 2 3 4 like that and up to the end, that means 1961 December. Okay, and then in the next column we will write the season. What is the season? This is a 12 monthly data, so each month is one season, we will assume, and therefore 1 to 12 is the season number. Now in the next period this will not be 13, this will again be equal to 1. So 1 to 12, then again 1 to 12, then again 1 to 12, and so on. In this way, we will complete the series up to 1960. So let me do that here. So this is done now. Now I will just zoom in the data so that you can see the formula in a proper manner. Also, I have copied these steps, that means the flow chart here, so that you can understand step by step. So what is the first step? First step was note the seasonal pattern, which we have already noted down using the scatter plot. That was a multiplicative model we have already discussed. So the next step is calculate seasonal averages. So we will calculate the seasonal average. How to do that? Seasonal average is basically the average of the months. That means in the first entry, the average of January, all the January months will be calculated. So how to calculate that? One method is just average this and this and this in this way until the end, but that is not a very efficient manner. So what is more efficient is using a average if function. So use average if function, and in the first argument there is a range. Which range is this? This is the range of the season. So select this entire season 1960 12 up to 1960 December, and make sure that you press F4. When you press F4, this entire range C2 to C145 is fixed. So when we will copy this down, this range will not change. So that is our intention. Therefore, we are pressing F4, function F4, in order to make sure that this is fixed. So in the next argument, we need to enter the criteria. What is the criteria? Criteria means we are doing average for what? For January month only. So January month is our criteria. So our criteria is equal to 1. So enter C2 here, because C2 is 1, and when we will copy this down, then this will be C3 and C4 and so on. And what is the next argument? Next argument is your average range. That means the average is to be calculated from which range? So naturally the average is from the passengers, the average of the passengers. So we need to make sure that we select the passenger column, and in this case also we need to fix it. D2 to D145 by pressing F4 will fix this. So once this is done, press enter. This will be the average of all the January months. Now when we will copy this down, this will be 235 is the average of all the February months, and so on. So if you copy this down up to 12, so this gives you the monthly averages. Now we will calculate the overall average of these numbers. So this is the overall average. And so now this is done. This step 2 is done. Calculate the seasonal averages. So this is done. So what is the next step? Next step is the compute the seasonal indices. How to compute the seasonal indices? So we will write seasonal index here. We will divide each seasonal average by the overall average. So E2 by E15. Again here we will make sure that we fix E15, because we are going to copy this down. So when we will copy this E15 should not change. So E2 by E15, E15 fixed, enter. And so we will copy this up to month 12, that is December. So note carefully that when we select this, the total is always 12. So this is the identification that you have done is correctly. So total of the all seasonal indices is up to the December, from January to December, should always be equal to 12. So once this is done, we will just copy this down. That means we will use the same seasonal indices for each year. That means the seasonal index of January, this is not going to change. In every year we will take this 0.862. So therefore we will take equal to this, and then we will copy this until the end. End means 1960, and we can extend it this for 1961 also, because same figures will be there whatever be the year number. So for 1960 also, 1961 also, 1962 also, this the set of seasonal indices are not going to change. So we have done this. So this third step is also completed. So what is the fourth step? In the fourth step, then we have to calculate the deseasonalized actual data. So this is the deseasonalized data. How to calculate that? We will just simply divide the passenger number by the seasonal index. So D2 by F2. This will give you the deseasonalized data. So see, this is a multiplicative model. We assume that we have two components. One is your seasonality, another one is your trend cycle. So if you divide the actual number, that means the passenger demand, by the seasonal index, that should give you the estimate for your trend cycle. So this is the deseasonalized data. This is the trend cycle, but since this is the trend cycle, so we will find an estimate for that, and we will use the linear regression method to find the trend on the deseasonalized data. So this is your deseasonalized data. We are going to find a trend out of that trend line. So what to do for finding a trend line? We'll perform a regression analysis. So in order to perform a regression analysis, there can be 5 methods in Excel. I have discussed this in my video, and the link of the video I will give this to you in this I button. So you can go to that video and check out. But in this case, we will select the best method used in forecasting, that is the trend function. So if you use the trend function, that will always give you the regression output for a given set of x and y. So here our known y's are the deseasonalized data. So in case of known y, use the deseasonalized figures as your known y value, and this is available to you up to 1960. So select that. Again, you know that you have to fix it by F4, G2 to G145. This has to be fixed because we need to copy this until the end. And what is the next argument? Next argument is your known x. So known x is your period number. So this is your period number. You have to select it. Not until the 1961. This has to be up to 1960 December. So this is your x values, and also make sure you press F4 here, make it fixed. And then finally the last argument is new x. That means you have given the y historical y value and historical x value. Now it is asking you what is the new x for which I will predict the y value. So the new x is anything, can be new x, but we are following this particular series. So I will start with period number 1, that is our new x. So B2, then we will close the bracket, and this will give you our trend line estimate. Now note carefully that it is also possible to extend this trend line estimate for the 1961 also, because we have the period numbers here. We just need the period numbers only, because the first two argument are the y values and x values of the historical figures that we have already fixed here. Now for the last argument we can use any period number. So for the future period number also this will work, and so the trend line can be extended for any number of periods, and for 1961 also. So once this is done, we are ready to calculate our final forecast. What will be that? This is a, you see the step is written already here. Reseasonalize the future trend using the seasonal indices. Reseasonalize means you just have to multiply the trend line estimate with the seasonal index. So that will give you the final forecast. So these are our final forecast. So now this is done. I will zoom out this once again and focus on the chart here. So see, the chart was developed only using the actual data. Now I will add the trend line data and the forecast data also in the same chart. So go to add. You don't have to enter any x values here because we have selected the scatter plot option. So in scatter plot they have some kind of algorithm. They use automatic x values. So don't worry about that. Just use the y values. What are the y values? For y values, first of all, we will select the trend line column. So this is your trend line column, this H column. I have selected that here and click OK. So this is done. This is you see, this is the trend line estimate, straight line, completely straight line because it is a regression data, nothing else. And then another series we will add here. Which one? That is the forecast. That is y value. This one, I column. So we will select this I column and click on OK and OK. So see, this is the prediction. The color is gray here. I will change this to red so that you can see it. So see, isn't it beautiful? This blue color graph is for the actual. The red color graph is your forecast. And this orange color is your trend line forecast. This orange color line is actually not required. Just to show you here. And you see the green, the blue color line ends here in 144 period. And then this is the projected demand for the next 12 periods. That means the 1961 forecast. So that's it. That is how you will implement the seasonal average method in Excel. Now in the maybe you were thinking that this is such a simple method. Why we are not using this in every case? Why we are sticking around and learning methods such as Winter's method and all? Those are really complicated. Yes, I agree that this method is quite simple and useful maybe, but this method has also its own limitations, and we will discuss all these things in the next video. And in the next video also we will see the second method of time series decomposition, which is the classical decomposition method, also known as the central moving average method. Until then, goodbye and thanks for watching this video.